Good evening, my dear students. I am here. Okay, fine. Priyanshu, you have got the question that I got the answer A and R both are correct. Yes, A and R both are correct, but it is not the correct explanation. It's a very simple thing that here the enthalpies of all element in their standard state is zero, but that does not define whether the reaction is going to be exothermic or endothermic. So organic compounds, when they show combustion, then in that case, the reaction is exothermic. The combustion is always exothermic reaction. For the carbon dioxide and water vapor, which are formed in the combustion of organic compounds, they are very stable compounds. Their energy is quite high, or rather, I should say, their enthalpy of formation is quite negative. That is why this is an exothermic reaction. But when we talk about this, the statement that element have the standard enthalpy of formation as zero, how does it define whether the reaction is going to be exothermic or endothermic? Is that clear, Tirthraj? Fine. Good evening, everybody. And there are 9 students who are watching, and there are only 6 likes. Where are the other likes? So we are going to begin over with it. And now we are going to talk about the second law of thermodynamics, the third law of thermodynamics, and the Gibbs energy. Now, before we get along with second law and third law of thermodynamics, I believe we were talking about the reading of NCERT, and this is what we were doing. Okay, so let's begin over with the reading of the NCERT. And once we have begun the reading of the NCERT, we have finished the reading of the NCERT to the topic what we have already done. Today, remember at 8 o'clock, we are going to do the questions of thermodynamics. So you need to be prepared for that, and you need to be very much clear about whatever we have done till now. Fine. And as usual, we have the same number of students that we are already having. That is, we have the number of students in the class as 9 or 10. Now it is 7. All students who are watching the session, have you liked it? You haven't. So all of you, have you read till this particular part? Thermodynamics chapter till this particular part? Have you read it? Now these are the standard enthalpies of the reaction. Are you reading it thoroughly, nicely? These are all definitions, and we have already done these definitions. And this is the questions that you are supposed to read through and do. Problem 5.6. Are you clear with that? Problem 5.7. Read it. Anyone has any confusions with these, any of the questions? Now, please remember, not to learn. Please don't waste your time learning these values. The only thing that you need to know is this. Wherever it is zero, those are the standard state. Clear? Only these things you are supposed to remember, that these are zeros. That's it. Fine. What happened to 5.7? Prerna, what happened to it? The entire solution is given to you. This is a long question, but not a difficult one. It is to be done in various steps. What do you want to ask, Prerna? Done? Okay. Any other problems anywhere? We have already discussed that, standard enthalpy of formation. I hope now you are able to read through the chapter of thermodynamics. Are you able to read through it? Read through it, read through it. Read it? Done? So we have done the topics till here. We have done all these. Now remember, not to be learned. Now this is not supposed to be learned, but need to be just go through it, just have an idea about it. That's it. Okay. Again, not to be learned. Okay. Now, fine. Now here is the lattice enthalpy. We have done this also. Have you read till this point? Have you read till this point? Any idea, any problem, anything you want to ask? Read through it. Read through it and just understand. We have done everything. Civil servants dream Lipsana. Lipsna. I don't know what your name is. Read it and ask anything you want to ask. Very few students here, and I believe you want to get 180 on 180 in chemistry. And if you want to do that, you have to do this. Read through it properly. Great, beta. Very great. All the best. Okay, everybody has read everything. You are not giving an answer. Anything you want to ask till this point? We have done till this point. Okay, done till this point. Everything done. That simply means that when I ask you the questions today, you will be getting all the questions correct. Do you agree with that? Today, you have to get all the questions correct. Am I clear? You say you have understood everything. Perfect then. So once we have talked about this, the NCERT topics, all topics, read through it, done. Now we are going to get along with spontaneity. So this is what we have as the batch which is starting very soon. That is on 5th August. Use the code WS Live. This is the code you are supposed to use. WS Live. Okay. अनन्या कभी कभी सिली मिस्टेक नहीं होना चाहिए. अगर कभी कभी सिली मिस्टेक हो जाता है तो उसका सीधा मतलब यह है कि यू हैव कभी कभी read the book. You have not read the book nicely, thoroughly. You didn't hear it everything clearly. You'll practice till 8. Fine. So that is WS Live you have to use. So this is what you are going to get in the batch. You already know perfectly what exactly is there. These are the timings. Learn these timings. You are going to be there. Okay. Fine. And this is the phone number that you can use. That's me. And now we are going to talk about something called spontaneity. Okay. What is the meaning of a spontaneous reaction? We have talked about the entropy. You remember, we have talked about the entropy, we have talked about the enthalpy, and we have talked about the second law of thermodynamics, which says that a reaction, any reaction which actually takes place, shows a net increase in entropy. Okay, how are we clear with that? Any reaction which actually takes place shows an increase in entropy. Okay. So when we talk about something called the spontaneity and we talked about the entropy, so for any reaction, or for that matter, any process to take place, net change in entropy must be positive. And when we talk about the net change is delta S total. Delta S total is delta S of the system plus delta S of the surrounding, and that should be greater than zero for any reaction to take place. Is that clear to everybody? So for any reaction to take place, the delta S total, that is delta S system plus delta S surrounding, must be positive. Clear? Okay. Now we talk about something important, a very simple important thing. Delta S is equal to Q reversible at divided by T. Delta S is equal to Q reversible by T. And this is when it is reversible. Reversible means it is at equilibrium. Reversible means it is at equilibrium. Okay? No process is actually taking place. Entire heat is being absorbed in the system and getting converted into the entropy. Clear? At constant pressure. If I talk about constant pressure, please remember when we talk about chemical thermodynamics is entirely done at a constant pressure. So at a constant pressure, Q reversible is equal to delta H, that is enthalpy change. Is it clear? So Q reversible is equal to the change in enthalpy. So delta S at a constant pressure, the change in entropy at a constant pressure will be equal to delta H by T. Now this is at equilibrium. Okay. Chemical thermodynamics is at constant P. Now it is not going to be mentioned. In this entire chapter, we do not use the P subscript ever again. It is absolutely understood that P is going to be there. So what we get is delta S is equal to delta H by T. Okay. This also would mean that delta H is equal to T delta S at equilibrium. Any kind of confusions here? Delta H is equal to T delta S at equilibrium. So that would mean that when we talk about at equilibrium, delta H minus T delta S is equal to 0 at equilibrium. Anyone wants to ask anything here? Okay. What is a PYQ? Now, if I don't have at equilibrium, then in that case, delta S minus T delta S is not equal to 0. Now, delta H minus T delta S is not equal to 0 if not at equilibrium. If it is not at equilibrium, then in that case, this is going to be a state function. Now, this state function is written as delta G. G stands for Gibbs energy. Some people call it Gibbs free energy, some people call it Gibbs energy, some people call it simply whatever, it's Gibbs free energy. So that is what we have as the Gibbs energy. So this is what we call as change in Gibbs energy. So delta H minus T delta S is equal to delta G. Now delta G again is of the system, or you may say delta G is overall free energy change. Now this is delta H of the system, that is enthalpy change in the system. Now this is minus T delta S again of the system, and that is equal to delta G, the overall Gibbs energy change. Any confusion? Okay. Now remember one thing, that is the change in the surrounding is equal but opposite to the change in system. So delta H of surrounding is equal to negative of delta H of system. Or you can say it otherwise, delta H system is equal to negative of delta H surrounding. Is this clear? So now if delta H system is equal to negative of the delta H surrounding, what we can get is that we have equation as delta H system minus T delta S system is equal to delta G. We can write it as minus delta H surroundings minus T delta S system is equal to delta G. इक्वल के बाद क्या लिखा है? इक्वल के बाद माइनस डेल्टा एच सराउंडिंग लिखा है और यहां पर डेल्टा जी लिखा है, यहां पे माइनस डेल्टा एच सिस्टम लिखा है. इज दिस क्लियर तीर्थराज? इज दैट क्लियर? एकदम ऊपर वाला का इक्वल की बात कर रहा हूं. ओके, इक्वल बट opposite to the change in the system. Now is that okay? Equal but opposite to the change in the system. So this is what we have as delta S surrounding minus T delta S system. Now you need to understand the change in surroundings is always reversible. The change in surroundings is always reversible. Because in surrounding, when you put the energy to the surrounding, it can't go anywhere. It has to stay in surrounding only. So surrounding takes up all the energy reversibly. Clear? So that is why delta H of surrounding is always equal to T delta S of surrounding. Am I clear with that? So if that is there, we get minus delta H surrounding minus T delta S system is equal to delta G. We get minus T delta S surrounding minus T delta S system is equal to delta G. Any confusions here? Okay. We can take out this T common because this T is the equilibrium or whatever the temperature is. The system and the surrounding have the same temperature. So T can be taken out of the system and we have minus T delta S surrounding plus delta S system is equal to delta G. Any confusions here? Now this becomes minus T delta S total is equal to delta G. Any doubts? Priyanshu Ghosh, Ananya Sarkar, Ritu Mittal, Zakir Saifi, Tirthraj, Pankaj Chaudhary, you said but. What do you mean by but? Clear? Now you need to know. The second law of thermodynamics says that for any reaction to take place, the net change in entropy must be positive. That is, delta S total must be positive for reaction to take place. Okay, Radhika beta, welcome. Okay. Now, if this must be positive for a reaction to take place, if this part is positive, T cannot be negative. It is an absolute temperature. T cannot be negative. Now, if delta S total is positive, T cannot be negative, then delta G has to be negative. Okay? Anyone has to ask anything here? So it simply means for any reaction to be spontaneous, delta G has to be negative. Every spontaneous reaction is accompanied by a decrease in Gibbs. Anyone has to ask anything here? Any spontaneous reaction is always accompanied by a decrease in the Gibbs energy. Fine, clear? So Gibbs energy must become negative. Clear? Now, before we get any further, let's talk about what is the meaning of spontaneous. Spontaneous also means feasible. That is a reaction which can proceed on its own in forward direction once initiated. Okay. Fine. So that is what we call as a spontaneous reaction. A reaction which proceed on its own in forward direction once initiated. You just need to initiate it and you need to provide the energy for initiation of the reaction and then it can carry on forever till the time it is completed. So that is what we call as the spontaneous reaction. Now spontaneity is a condition dependent case. Spontaneity is condition dependent and specifically temperature. So spontaneity is temperature dependent. Delta G could be positive, delta G could be negative depending on the temperature. Okay. Now what we can see is now delta G is equal to delta H minus T delta S. There are three temperatures. One is called T equilibrium. At T equilibrium, delta H is equal to T delta S. Delta H is equal to T delta S and delta G is 0. Fine. And then we have high temperature. High temperature. High temperature means T is greater than T equilibrium. Then we have something called the low temperature. Low temperature means T is less than T equilibrium. Fine. At high temperature, magnitude of delta H is less than magnitude of T delta S. At high temperature, magnitude of delta H is less than the magnitude of T delta S. Fine. So, sign of delta G is opposite of delta S. If delta S has a negative sign, delta G will have a positive sign. If delta S has a positive sign, delta G will have a negative sign. I'm not bothered about what the sign of delta H is. Any confusions? Ananya, everybody gets the problem in her assertion reason type question. So you need to do it thoroughly. Pankaj Chaudhary, Haber's process is spontaneous or not? Haber's process is spontaneous process. Okay? That is why it takes place. Any confusions here? Anything you want to ask? So this is delta G, sign is opposite of delta S. Fine. Now, at low temperature, magnitude of delta H is greater than the magnitude of T delta S at low temperature. Fine. So the sign of delta G is same as that of delta H. Read that two statements. Any confusion? Anything you want to ask here? Anyone has to ask? Ritik, welcome. Think again. This part is very important. So what we do is, see, understand that delta H is negative for exothermic reactions. Okay. Delta H is endothermic. Delta H is positive for endothermic reactions. Okay. Delta H is positive for the endothermic reactions. Fine. Now, how to find where delta S is positive or negative? A reaction in which products have more gaseous moles than reactant, delta S is positive. A reaction in which products have more gaseous moles than reactant, delta S is positive. Okay, so delta S is positive. Clear? And a reaction in which products have less gaseous moles than reactant, delta S is negative. You have to learn it. Ritik Prasad, we are going to have some questions, some NTA questions, some normal question, exemplar question, all kind of questions. Okay, I have my own different source. So a reaction which products have less gaseous moles than the reactant delta S is negative. Now, now the third part is a reaction which does not have gas or reactant and product have same number of gaseous moles. Delta S may be considered zero. Noted it? Is this clear? Have you noted it down thoroughly? These statements, because these are the statements that you miss and that simply ask, sir मुझे कैसे पता चलेगा कि डेल्टा एस पॉजिटिव है या नेगेटिव है? सर मुझे कैसे पता चलेगा किसमें डेल्टा एस जीरो है? Read them thoroughly. Noted? Fine. Now let's have the things. What we find is now this is what we are going to do. Delta H could be negative, delta H could be positive, delta S could be negative, delta S could be positive. Delta H could be 0, delta S could be 0. Anything, anywhere. Now we have a table. Here we have the delta H. Here we have delta S. Here we have delta G. Now delta G is at 2 points. High temperature, low temperature. Okay. Let's say So here we have low temperature. Clear? So here we are going to talk about what would be the sign of delta G and whether the reaction is going to be spontaneous or non-spontaneous. Is it clear? So if delta G turns out to be negative, the reaction is going to be spontaneous. If the delta G turns out to be positive, the reaction is going to be non-spontaneous. So here, let us say we have delta H as positive and delta S also as positive. So what happens at high temperature? I have just told you, go through your notes and give me the answer. If delta H is positive and delta S also is positive, at high temperature, what will be the sign of delta G? At high temperature. Tell me whether delta G is going to be positive or negative. Yes, at higher temperature, this is going to be negative and the reaction will be spontaneous. It's something like boiling of water. As the temperature increases, the water vapor becomes more stable. Now, what happens at low temperature? It is going to be positive and the reaction is going to be non-spontaneous. Clear? Now, next question. Let us say we have delta H as negative and delta S as positive. So at high temperature, delta G, will it be positive or negative? Answer, it will be negative and it will be spontaneous. It will be again negative and it will be again spontaneous. At high temperature, the sign will be opposite of delta S, so it will be negative. At low temperature, it will be the same as delta H. It will be negative. Okay. Now let's make it, here it is positive and here it is negative. Now tell me, This is going to be positive and non-spontaneous. This is going to be positive and non-spontaneous. Is this clear? हाँ तीर्थराज, इतनी देर से मैं आपसे यही कह रहा हूं. बोला था ना that for a reaction to be spontaneous, delta S has to be positive, total. And if delta S total is positive, delta G has to be negative. Then only a reaction is spontaneous. Okay. Okay. Now let's have this as both negative. Both negative would mean higher temperature, it is going to be positive and non-spontaneous. At low temperature, it is going to be negative and it's going to be spontaneous. This table you have to learn by heart. Anybody has any confusions with this particular table? Anything to ask here? This table you have to learn. Okay. So that is what we have as delta G. Okay. Now, having talked about this delta G, let us understand what exactly is delta G. Delta G is called the free energy change. Delta G is the work done by the system. It is the work done by the system over and above the expansion or the equilibrium work, over and above the expansion work. So delta G is actually negative of W useful that we get over and above the expansion or the equilibrium work. अब equilibrium का मतलब क्या हुआ? Let us say your salary is 50,000. Out of that 50,000, you use 20,000 for food, clothing, and shelter. You use another 10,000 for education. Okay. And you use another 10,000 for your investment. You spend 40,000 to maintain your life. You have 10,000 left to be spent as you like. Now, this 10,000 rupees, obviously that is your earning, but this 10,000 is what we have as the free money, which can be used on something called luxury. Okay. Every advertisement that you see, every advertisement that you see is for this particular 10,000 rupees because this doesn't need to be advertised. Clear? So this free energy, the change in free energy is actual work you can extract from the system for yourself. Is this clear? Fine. Now, delta G is also related to the equilibrium. Delta G is equal to minus 2.303 RT log K. Now, actually, this is Kp, that is at a constant pressure. And this gives us the extent of the reaction. Is this clear? Is this clear? So now let's talk about the NCERT once again. Just read through it. Just read through it. Read through it. Read through it. Read through it. Anything you want to ask here, just ask it. Are you reading it? Anybody who has not liked the session as yet, just go ahead and like it. Sir, it means to say that any spontaneous reaction proceeds from higher energy towards lower energy, but you need to define which energy, Priyanshu. You have to define which energy. It is the Gibbs energy. Every spontaneous reaction moves from the higher Gibbs energy to the lower Gibbs energy change. Clear? When the Gibbs energy reaches its minimum, not zero, its minimum, the reaction reaches equilibrium. Delta G becomes zero and the reaction reaches equilibrium. Okay. For all visible purposes, the reaction stops. I'm saying all visible purposes because the reaction continues in both the direction at the same time and it balances. The two steps balance each other. Okay. Are you reading it through? Whatever I have told you, using that you will be able to understand it. Otherwise, you would not have been able to understand it. Problem 5.0, 5.10. Go through it. Reading it. Read it. Read it. 3 minute break. Ananya, we are gonna finish off the class in 3 minutes. So we don't need a 3 minute break at the moment. So what you need to do is within the given time till 8 o'clock, you have to read this particular chapter. We have done all of these. And we are going to do the questions at 8 p.m. Okay? The thermodynamics chapter is over. We are going to meet at 8 o'clock. I hope you are up to it. So I hope you remember we have the biggest offer yet, an iconic mega sale week, and this is the schedule along with 10 a.m. class of chemistry. Is this clear? Great, it is understandable. So read through the NCERT and we are going to do huge number of questions. Whenever you get a good question, we are going to solve it. I believe everybody has already joined and followed me. Bye-bye. We are gonna meet in 30 minutes again. Bye-bye. Take care. Good night. Good night, Nee. Good evening. We are gonna meet once again at 8 o'clock in special class. So we are going to meet in the special class. Bye bye. Take care.